Okay, we're going to go through this installation of a 4-path FS230. It has the external DSL. So the first step is going to be to take a measurement using a tape measure for the circumference. And then you're going to calculate the circumference divided by pi. You'll come up with an answer. This is a 30-inch pipe, I guess. Then it wants you to take a wall thickness measurement. So we'll do that. First, you'll need to put some grease on the probe. You may have to remove some of the paint. Especially if the paint's really thick, you might end up only measuring the thickness of the paint. And then they want you to get rid of this screen here. Take the measurement. In this case, it's a 0.375 inch wall. So you'll make a note of that somewhere. And the preparation step is done. Now we could move on to the transmitter and DSL connections. So let's do that. And there's our DSL. Let's go to the next step. There's our mounting bracket and our U brackets. Get mounted on the 2-inch diameter pipe like this. Okay, you got to put some bolts, or some nuts, I should say, with washers. Move the external DSL into place. Secure the Allen bolts, or secure it with the Allen bolts. Okay, in this case, they're showing us a industrial mounted transmitter. We already did a different video for the wall mount, so you could refer back to that one in my other YouTube videos. Okay, this is kind of self-explanatory. So now that you get the mount in place on the 2-inch diameter pipe, you want to grab the external DSL, but first it looks like you take off this nut, put it in place, and then tighten down the nut. Okay, now we're over at the external DSL again. You want to loosen the screw, remove that top cap, and here's where your I/O ports are. It's telling you to remove this access port and affix the gland. And you can always pause each of these steps and just look here for the step-by-step instructions. Okay, this looks like the SSL, I'm forgetting. The sensor link cable between the DSL and the transmitter. Nope. Well, is it or isn't it? Let's see. Yeah, sure is. Okay, it gets plugged into that spot right there. There's over here to the far right is your power, and then next to that is your data, A and B. Okay, it appears to be color-coded. You want to tighten down these screws. Okay, tighten down the gland. Okay. And here is your industrial transmitter. Loosen the set screw down here at the bottom. Unscrew that cap. Then we have another plug here we're going to take off. And we're going to switch that out for a gland. Take the other end of our SSL cable, our sensor link cable. Thread that through. Grab a hold of those wires. And hook up the colors as you see them here. You can always rewind the video to see how we did the other one. Maybe make a screenshot. Put the cover back on. And it says, don't forget the O-ring. And then once you have the O-ring in place and then the cap, you could do the set screw. What do we have next? We have to take off this cover. This, I believe, is the mains power. So, okay. They want you to take off this blind spot here, this blind plug. Put another gland, and this is where your mains power is going to go. Feeds through, kind of snakes around the back here. You pop open this lid, and it's going to show you how to land it. And we are both literally going through this together at the same time because I have not installed one of these industrials in the field yet. There's the live. Here in the US, sometimes we call this the hot. And that's the neutral. These colors are not familiar to us. I guess these are European colors. Okay. Pop the lid closed for the plastic lid for the power. Don't forget your O-ring. And put this guy back on. Tighten down your gland. I'm trying to tighten it. Am I stuck here? Do I have to hit it? Oh, I have to. This one, it made me click on it. And now we're finished with the second part of this, mounting the transmitter and mounting the DSL. So that takes us to this next step, which is programming and installing the sensors. And let's hit this. We're going to start out in Expert. Put on our pin, which is 2834. It should show up here. Well, it doesn't say it here, but it is 2834. Go to the Quick Start. Quick Commissioning. Or you can just drop down to Sensor Settings. Either one works. And let the wizard guide you through. Set up the units for the country that you're in. Here we use inches and Fahrenheit. Then hit Next, which brings us to pipe characteristics. If you remember from before, we jotted down our pipe information. That pipe happened to be carbon steel. And let's see what we do here next. Okay, there it is. 30 carbon steel standard, which is what those measurements equated to. This pipe expansion, we typically skip this. We leave the default values that are in the menu. So we'll just say no. Then on this, we know there's no liner, not usually in a carbon steel pipe. So we say no. We generally leave the inner pipe roughness for steel as you see it here. Your inlet and outlet conditions depend on your pipe layout, but for this illustration, we'll say no, which just means that we have plenty of up and downstream diameters. Sensor selection, yes, this would be the next thing. Oh, there we go. You want to pick up your sensor and you want to read what type it is. And here it tells you it's an FSS 200 high precision. And then we want to select that. And then there's the size right below the model. And the size is D1H as in Henry. And we go down to that, D1H. And then our temperature code, it's T1, which most of these will be. And it tells you, I think it tells you there, what the temperature range is. Or actually, that might be the whole entire range. But anyway, it's D1H, T1 temperature range. There you go. There's the range. Or less than 176 Fahrenheit. And there it is. And we can go down. However long our cable's in, we can put this in here. 10 feet would be good enough for this example. Next. Now we come to medium characteristics. Whether this is water, gas, hydrocarbons, or something else. This happens to be a natural gas installation. There's our expected sound speed. Now, one thing I would like to mention, it's always best if you use the FSS 200 sizing tool to calculate this based on your true gas composition. It'll get you the best spacing, but more importantly than that, the search region for where the signal will appear is highly dependent on this, and this becomes more critical the larger the pipe size. So consider taking the additional step of calculating based on your gas composition what the expected sound velocity happens to be. Then we hit next, and now we come to configure paths. So this, I'm guessing, is a 4-path, as we said earlier, and each time you go to the next row, you hit the right arrow to enable or fill in all the check boxes. Then you go to next, and now you have to go through these one at a time. A lot of mistakes people make is they get to this step and they'll skip this and they'll go right to next, and no setup is completed. So we're going to choose the right arrow, and there's our pipe geometry. We have some choices. Direct means a single diagonal across the pipe. Sometimes we refer to that as a single pass, P-A-S-S. Reflect means that there'll be a bounce or a single bounce. Some people call this a V. 3 traverses means there'll be a first and a second bounce. Reflect, by the way, 2 traverses, both sensors are on the same side of the pipe. Reflect 3 traverses. Actually, this should probably, I think I wrote this up as a bug. This should probably say direct 3 traverses, because one sensor will be on one side, and then 2 bounces later, the other sensor will pick up the signal. And then finally, the reflect mounting 4 traverses means that the beams will make like a W. So basically, it'll be, let's say, 1, 2, 3 bounces. So I don't know if I said this one right. This would be 2 bounces. Let's see. 1, 2. Yeah, this would be 2 bounces. No bounce, 1 bounce, 2 bounce, 3 bounce, if that makes sense. Let's go. We're going to, again, I decide which one of these I'm going to select based on what the FS200 sizing tool tells me. And that's very important because the meter by itself will not calculate the best selection here. So always defer to the FS200 tool calculations to tell you how to mount this. This is very important. Okay, next we come to the recommended spacing. This is important. Let's see what this says. Note the number index value. This value corresponds to the index marked on the spacer bar. Okay, you'll see what the spacer bar is in a minute. What they want you to do here is condition the pipe. They want you to clean it, degrease it, maybe give it a light sanding, clean off that dust, degrease it again, and then you're going to have to apply dampening material. And they come in these strips, and the number of layers are based on the sensors that you're using. Remember, we're using D1H sensors here. What does it want me to do? I have to touch this or something. I guess I have to roll this. Yeah. Okay. So they want you to put it on and roll it flat. You want to make sure there's no bubbles. And by the way, okay. So, all right, it's kind of jumping ahead here. So, by the way, the FS200 tool will also tell you how many layers of dampening you need, and it will know that based on the sensors you've inputted into the tool. So these are the hold downs for the straps, and again, you can always read this little blurb here. You can hit pause at any time. But now here's an important step. A lot of people I notice when I go up, follow them out in the field, they only wrap the strap around twice. This strap needs to be wrapped around, wait, did I say twice? They only wrap the strap around once. This strap needs to be wrapped around the pipe twice. But to start with, you're going to put this little keeper on here. It's got the little spot for the Allen screw. You want to bend this part over. Okay. And then on the opposite end of the strap, you want to put 4 of these on here because it's a 4-path. Okay. And then, yeah. What's it doing? Oh, okay. There's the second wrap. Okay. So now the entirety of the pipe has been double strapped, and then you can tighten down the little Allen set screw. It shows here a little cross cut screw, but it's an Allen screw. Tighten that down and repeat that process. Now, it doesn't go into it, but you should space these out evenly depending on how many paths you have always. And let's continue. And here are your mounts. These are the stainless steel precision mounts. And by the way, here's your spacer bar in the background. Okay. And here is the one side is reference, and then the other side will have um, the spacing index that we wrote down earlier. So let's continue. Sometimes it might say if these are D size sensors, there might be a hole to thread this into that says D versus E. So remember that. You want to, since our sensors are D, you want to use the D hole and not the E hole. And then I guess our spacing was 27 because that's where they're putting it in here, although I neglected to write it down. Okay, and it kind of helps if you get these bands all in the right spacing before you try to. This is relatively heavy, so if you don't have it lined up in advance and then you come over here, you're going to have a hard time getting the holes lined up with the studs. Then you got the washers and the first course of nuts that you're going to tighten down. And this is the point where I'm kind of just doing it snug enough so that the weight of the enclosures are not pulling it down with gravity. Okay. Not sure what it's showing me here. I guess I should read it. Visually verify that the enclosure housing is in line with the pipe. Okay. So what you could do is you can use this, we'll call it we'll call the pipe the horizon. And you can line up this. If you stand back at the right angle, you can see that this lines up. If your pipe is extremely level, you can use a level. But yeah, there you go. Okay. All right, there you go. Okay. So just make sure everything's level. Make sure that everything is in line as well as it can be. And now you could fully tighten all of these, provided they haven't moved in place. And then these are the keeper nuts that go on so they won't loosen after you've done so. You can put all those on. I'll just click past this step. Okay, now you have to identify what direction your flow is in. And where the flow is going to, in this case, it's the left side. That's your down. So let's grab a gland and a F connector. These go on here. I do have some videos that show you how to properly strip this cable. These are twist-on connectors. Oh, that was just showing you the gland. Sorry about that. This is the step I was talking about. This has to be stripped correctly. Check out one of my other videos to see how to do that. Okay, grab the sensor, screw it on. Come on. Put the glands back in, tighten those down. Now you want to apply the grease, which it didn't show it, but you just apply a thin bead right down the center. Put it in place. Now this is how you're going to torque down the sensor. It kind of slides on a diagonal. There's slots on both sides here that it fits into. Give it a turn so that it's in place, and now you can tighten down the worm screw. There should be, when you receive this, 2 sets of worm screws. One is shorter if you're using the E size sensors, and longer if you're using the D size. So Don't throw anything away in your box when you open it, because those worm screws might be, the correct worm screws you need might be inside a bag inside the box. Okay, tighten that down, put your lockdown nut. Want to do the same thing for the upside. Glands, F connectors, sensors. Yep. Tighten everything down, put your grease, pop it down. Put this guy in the way we did the first one. Tighten it down. The lock nut. Now you can, I don't usually close this until I'm done, because generally I make a mistake somewhere along the line, then I'm taking things off again and losing screws and the like. But here we have it buttoning it up. We're very confident that it's going to work, or somebody is. Do this for all 4 paths. This shows an RTD, which is an insert type. But we also have ordinarily we have the clamp-on type in most of our installations. Okay, this is important. It's very easy to mess up. You'll notice that on one side it's 1, 2, 3, 4, and then mirrored on the opposite side it's 1, 2, 3, 4, which means that 1 on this side goes with 1 on the other side. One side is A, the other side is B. A means upstream. I don't know why they didn't just call it U. And B is downstream. It would have been good if they would have just called that D, but they did not. Okay. Use that tool. Alternately, you can change these out for slip-on types, but if not, you need to use the tool. And the next step should show you how that works. It slips in, you spin it around, and then they tighten. Tighten up your gland and do this a bunch of times. So now you notice we're on the opposite side. This is the downside, this is the upside. That's also things that people get wrong in the field. Then just do it 4 times. Now we can go down to next. Hit the right arrow, and hopefully we see a receive signal. If we don't see a receive signal, take a look at my troubleshooting videos. You can hit the left arrow when we're done looking at that, and then go down to next. And then we do the same thing for path 2, and so on and so forth. Same thing over and over again. This is really going to go through it 4 times? No. Okay. All right, now we're complete with that. What do we have left? Let's see. Oh, nope, we're done with that section. Now we come to the final steps of connecting the pressure and temperature. Okay, and here's this is a Siemens PT1000 RTD. At least it should be. It doesn't have to be Siemens, and it doesn't have to be insert. It just has to, it could be PT, what is it, 100, 500, and 1,000. It could be a 2, 3, or 4 wire, but we'll go through those steps. So where does it have us? It looks like they want us to take this plug off. slip on the gland, slip the wires through the gland. Okay, and it's just showing a bunch of loose wires right now. I have no idea what this part is. I've never seen it before. Let's find out what it is. Oh, it's just a ground lug. It's just a terrible depiction of a ground lug. Okay. And now notice this is channel 5, right? That's what we always use, channel 5, not channel 6. That's reserved for, well, this part is future, and we'll get to this other part in a few minutes. But the channel 5 RTD, notice you can also use, instead of an RTD, a temperature transmitter over here, and that's what this 4 to 20 input is, channel 5 plus and channel 5 minus. But people will often ask me, I'm not sure which wires, because the color codes are wrong or something like that. So there's 4 of these, right? And if before you land them, these 2 will read close to 0 ohms. So in other words, not plugged in here. They should read close to 0 ohms to each other. In this case, it's the red and the green. These 2 will also read 0 ohms if you measure them when they're not connected. Any one of this pair to any one of this pair should read about 1,000 ohms. So that's how I always know, in case I get my wires mixed up, and it's happened plenty of times. I'll find which pair are 0 ohms and I'll put them on the left. It doesn't matter if I put them on the left or the right. And then the other 2 pair should also be 0 ohms, and it doesn't matter. As long as I put 1 0 ohm pair on the right and 1 0 ohm pair on the left, we're good to go. Now be careful about this ground if you have a cathodically protected pipe. Sometimes I just snip this back to play it safe, because we don't want the cathodic protection to be feeding back to the ground like this. Let's say there's some current on the pipe. We don't want that feeding back. So most of the time I'll snip this short, and I'll just use the ground on the sensor side, not on the transmitter side. Okay, so now we'll tighten this down, I guess. I'm not sure why they're showing me this. Oh, that was the pressure. Okay, that's the pressure transmitter coming next. Okay, so now same thing, same routine, gland, cable. Now this should be a 2-wire because it's just a 4 to 20, right? And here's what I was saying. Channel 5 we typically reserve for temperature. Channel 6 is our pressure. So we land the plus on where the plus belongs, and the minus where the minus belongs, and tighten it down. Okay, back to our, and I have other videos on this too that specifically deal with RTDs and pressure inputs, so you might want to check them out. Back to quick start, oh no, not quick start, go to setup, go down to inputs and outputs, go down to channel 5, and remember I told you, well, first we got to enable it as a RTD. And again, if you do have a temperature transmitter, you would be selecting this guy, which would be a 4 to 20. But in this case, we have a true RTD, so we'll do medium temperature RTD, right arrow. Okay, process value, medium temperature RTD, RTD configuration, PT100, and here are our choices. This one happens to be PT1000, which gives you the highest resolution, by the way. The higher the resistance gives you the better resolution for your transmitter. Not transmitter, RTD. Typically, we sell the 4 wires for this application or include them. And then what happened? Am I stuck in a loop here? Oh, I don't know what that was all about. Does it let you go back? Let me see. I think it does. I didn't go back far enough. Because there's something they kind of skipped called the wire resistance. But if you know your resistance per foot and you know how many feet you have, for further precision, you can put in the wire resistance with a little calculation. Now we go to 6, which is pressure. So this time it's going to be a current input as pressure. You have to establish what the upper range value is based on what the transmitter is set for. Okay, in this case is 1,000. And then the lower range, in this case it is 14.7, which is basically atmospheric pressure. And what else? I think that's it. And what is it giving us a tour here? What are we doing? It's just showing us that we're done. Yep, showing us that we're done. So that's it. We completed all these steps. Each individual parts, or many of these parts, I have gone through in much greater detail in other videos, but this gives you a 40,000 foot overview on what it takes to install the meter. That's it. Hope you enjoyed it. See ya.